so today we will be starting motion in 2 dimensions. Okay, so this is CBSE 11th standard, chapter 4, isn't it? Chapter 4, that is motion in a plane. Correct? So we will be starting today motion in a plane, and the previous chapter we have already studied, that is motion in a straight line. Okay, so our previous chapter was related to motion in a straight line. Motion in a straight line. So motion in a straight line and motion in a plane. What is the difference between these two?
One dimension.
Okay, so motion in a straight line, it is in one dimension. So you can say that any type of motion which is taking place in one direction, okay, only in straight line. If suppose any motion which is taking place in a straight line, it may be forward, it may be backward, but only in a straight line, then that type of dimension, or we can say that only in one axis. Suppose if you are going for any axis, so only in one axis, that is x-dash, and x if we are taking it as origin, so only in one axis if the motion is taking place, either forward or backward, it will be categorized under motion in a straight line. In that motion in a straight line, we already studied about equations of motions. Okay, so those equations of motions are, so we studied about 3 equations of motions, isn't it? 3 equations of motion, apart from discussing about displacement, velocity, acceleration. Okay, so we discussed about displacement, we discussed about velocity, we discussed about acceleration. Okay, we discussed about average velocity, we discussed about average speed. Okay, so all those things we have already studied. See, one more thing we studied, that is called deceleration. See, deceleration, actually, the word, you know what is deceleration? Okay, but you know acceleration, isn't it? So we studied about displacement, then second we studied about velocity or speed also, similarly here distance also. Then third we studied about acceleration. Did we study about acceleration? Okay, so acceleration will be there only when there will be a change in velocity. If there is no change in velocity, there will not be any acceleration. So that point you have to remember. If in any question it is given that the body is moving with uniform velocity and there is no change in velocity, then absolutely acceleration you take it as 0. Correct? Okay. Right, there is a word which is called deceleration. Deceleration word, actually it is not coming under that physical quantity like displacement, velocity and acceleration what we have. According to that, deceleration is not the word which we should use. Deceleration word is used for negative acceleration. Negative acceleration means what? Yes, of course. So when the body is moving forward with change in velocity, you will be saying it as positive acceleration. You will be saying it as positive acceleration. Okay, so when you are increasing the speed of the vehicle, so the vehicle is moving forward at higher speed, change in velocity is taking place, then you can say that it is positive acceleration. But when you are applying brake, at that time what happens? At that time, the velocity is decreasing. The velocity is decreasing, not increasing. Velocity is decreasing. When velocity is decreasing, it is giving us the value of acceleration as negative. Okay, so that is called negative acceleration. So deceleration generally we are using in English. In English, deceleration word is there. Deceleration means reduction in velocity or reduction in acceleration. But as we are using displacement velocity, a physical quantity like this, deceleration is not there. Okay, so in place of that acceleration, what we call positive acceleration or negative acceleration. Okay, very good. So these concepts are very clear to you. Then we also studied about three important equations of motion. Three important equations of motion on the basis of which we solved many questions. Correct? Numerical problems. Like when you are knowing about initial velocity, final velocity, okay, displacement. So we studied about, so one is final velocity is equal to what? Initial velocity plus acceleration into time. Okay. So that acceleration, what it was, the definition of acceleration was saying what? It was saying that the change in velocity. So final velocity minus initial velocity per unit time was given to acceleration, and from that only this v is equal to u plus at is derived. Okay, so you have to understand that what at is there, from where this equation of motion has come. Another equation, that is v square is equal to u square plus 2as. Okay, so this was the equation. And third one, where we are finding displacement, that is s is equal to ut plus half at square. Very important. So these three equations of motions are very important. Even in motion in a plane in 2 dimensions, we will be utilizing all these equations of motion. So these equations of motion everywhere it will be utilized. When we are talking about projectile or when we are talking about any vehicle motion in 2 dimensions, these equations will be there. Right? Understood? Okay. Now, the same equations of motions were utilized for some falling body or if the body is moving upward. Correct? Same equations of motions were there. So what change will come here? Acceleration. This acceleration will get changed to acceleration due to gravity, that is g. Okay. So when any body is falling towards earth, it is assumed that g will be positive. Okay. So g is positive, and when it is moving against the acceleration due to gravity, against the force of gravity, means upward, then what will be taking acceleration? That is minus g. Will be taking as minus g. Very good. So this part already clear to you. Right. So motion in a plane, when we are discussing about motion in a plane, so there is a requirement to understand vectors. Okay. There is the prime requirement to understand vector. Right. So in earlier classes also we had a very good discussion on scalar quantity and vector quantity. Okay. So let us have a little you can say discussion once again for refreshment, or we can say little bit recalling it back. Okay. So I will be asking you that what do you mean by scalar and what the meaning of vector. Which type of quantity you will be calling it as scalar quantity, and which type of quantity you will be calling it as vector quantity. Yes. Okay. So making you to recall what we have studied earlier, let us have a recall of that. You can start noting it down also. So as we need to discuss about vectors first. Okay, when we are discussing motion in a plane. So motion in a plane will consist of motion in 2 dimensions, where x and y axis will be there. Correct? Even motion in 3 dimensions also will be coming under this category. Right? Okay. Now, scalar quantity. Because it is very important to know that what actually is the meaning of scalar and what actually is the meaning of vector. Okay, so scalar quantity, and another one we are having vector quantity. Right. So in scalar quantity, actually what it is there, those quantities which are having magnitude and direction both, they will be called as vector. And only magnitude, magnitude, the quantities which are having only magnitude, they will be called as scalar quantity. Okay? So can you give an example which is having only magnitude? Which type of quantity we will be calling it as scalar quantity? Any example?
Speed.
Speed. Okay, very good.
Acceleration.
Which one?
Acceleration.
Acceleration. Acceleration is a vector quantity. It is not a scalar quantity because it is velocity, change of velocity by time. Velocity is the vector quantity. Okay. Any example for vector quantity? Acceleration. Okay, just now we have discussed. Right. Temperature will come under scalar quantity because it is not having any direction. It is having only magnitude. Okay. Right. So we will write as those quantities which have only magnitude. Only magnitude are called scalar quantities. Right? So example, you can say as mass, density, volume, temperature, energy, work. Okay? Then charge, current. Understood? Speed, distance. So these type of quantities, etc., we can write it as etc. These type of quantities are having only magnitude, no direction. Correct? Okay. Now vector quantity, those quantities which will be having magnitude and direction both. Right. So we can write those quantities. 100% in examination it will be coming as differentiate between a vector quantity and a scalar quantity. Okay. So those quantities which have magnitude as well as direction are called vector quantities. Okay? So example, velocity, displacement, then acceleration, then force, momentum, momentum will consist of angular momentum also. Okay, angular velocity also will come under vector quantity, angular speed will come under scalar quantity. Okay, etc. Right? You have understood now that what is scalar quantity and what is vector quantity? Right. Okay, very good. Noted down? Yes. So a vector quantity will always be expressed. A vector will always be expressed by special notation like one arrow will be placed at the top. Okay, so what it shows? It shows that it is having some direction, right? So A vector or B vector. Some places you will find that like this cap also will be used. Okay, so this cap is generally used to represent unit vector. This cap is used generally to represent unit vector. Unit vector means what? Unit means what? What is unit? Okay, so this is actually unit vector. Not that unit. I am not talking about that unit as meter and kilometer like this. Those units we are not talking about. Meter and kg and second. We are talking about it is called unit vector. Unit vector means magnitude 1. Unit vector means magnitude 1. Okay, so those vectors which are having magnitude 1 will be denoted by C and cap. One cap will be there. Okay, so this like this also notation will be there. This is also representation of a vector. In general, vector will be represented like this. Okay. Now we will be discussing about position vector and displacement vector. Okay, let us go for so position vector and displacement vector. Position vector and displacement vector. Now, suppose any two-dimensional axis is there, x dash and y dash. In this two-dimensional axis, suppose at any point P, and now this is origin, right? So from origin, this point you can say this is the length OP. OP is the vector. Understood? So now this point P, actually it is showing position vector. It is showing the position of this particular point with respect to origin. With respect to origin. Okay, you can also say that this point P is located with respect to x-axis, with respect to y-axis. Okay, so it will be having two values, that is x and y. Its coordinate will be located as x and y. So that x will be what? So whatever this value, this distance is on x-axis, so that is x. And what is y? So once you are finding this distance, so this distance will be giving as in y-axis, so this is y coordinate. So x and y coordinate, this position P, particularly that point P is located at what point with respect to origin or x and y axis, with respect to x and y axis. With respect to origin, so this distance will be giving you that at what distance this P point is located from origin. Direct distance. Correct? Okay. So this particular location of that vector is given by position vector. Okay. So this position vector here we will be writing as OP. OP and then vector. So this is called position vector with respect to O. The position vector of point P with respect to O is OP. Understood now? Okay. So suppose any point P at any instant of time T is located at coordinates, you can say that x1 and y1. x1 and y1 that point. Coordinates x1, y1. Okay, so then the position of the point P with respect to O means origin, with respect to origin O can be represented as OP vector. Can be represented as OP So generally, if you are given that this vector is written as R, generally this vector is written as R, so it means this R is the position vector of this point P. Okay, so this is OP. And how that OP will be represented? So OP will be represented as, so X coordinate is there. Okay, and now on X axis you are knowing that unit vector I used to be there. You know about IJK? What we are using IJK. Okay, so along X axis it will be I unit vector. Along Y axis unit vector J, unit vector J. Along X axis unit vector I. Okay, so if you want to represent its location OP in terms of its axis, so you can say X1 I unit vector plus Y1 J unit vector. Suppose if you are going for three-dimensional axis, if you are going for three-dimensional axis, then one more it will come here. What? K. So you can say that Z1 K. So in more detail we will be studying later on. So this is the position vector. This will be called as position vector. Understood now what is position vector? Okay. Whether you have noted down? Note it down. Then we will discuss displacement vector. Okay. Right? Okay, good. Now we will go for displacement vector. So displacement already we studied. What is called displacement? The shortest distance
Shortest distance traveled between the 2 points.
between 2 points. And what are those 2 points? Between initial point and final point. Very good. So displacement is the shortest distance, isn't it? Shortest distance between initial and final point. Correct? Okay. So now suppose you take any vector, or you have taken at one instant of time this position as P, which is having coordinate as x1, y1. Correct? At one instant of time, suppose at point at T. Now at any other instant of time, this point P has moved to some another location P dash, where x2 and y2 it has become. This point P has moved. So now with respect to origin, this will be having this vector, correct? So this is O and this is P dash. Okay? And this is at some instant of time, you take it as T dash. So now that point, initial location was here. Now final location is P dash. So it has displaced from one place to another. Okay. So this particular, this is called displacement vector. Correct? So from with respect to origin, earlier the point was at P. Now with respect to origin, this point has moved to P dash. Okay, so this has got displaced. So you can say in this direction it has got displaced. Okay, so now this P dash is the main displacement vector. P dash is the main displacement vector. Okay, so that is called a displacement vector. So when the point or position. Changes its position with reference to. There should be some reference. Okay. So with reference to, here we are putting origin or x-axis, y-axis. With reference to origin. 100% with reference to should be there. Okay. So when the point or object changes its position with reference. With reference to origin or coordinate axis. The change in initial point and final point is denoted by a vector called displacement vector. So in examination, it may come that differentiate between position vector and displacement vector. Okay? So position vector at a particular point with reference to origin, and displacement vector when that point has moved to new location. Okay, so then that will become a displacement vector with reference to origin called displacement vector. So in this case, PP dash is the displacement vector. Okay, and that PP dash will be what? So P dash, correct or not? PP dash? Yes or no? PP dash will be equal to OP dash minus OP. Okay? OP dash minus OP. Before that, suppose if you are having any doubt, let me tell you about a vector addition and other things I will tell you. Okay. So, in that, suppose a vector is there, any vector A. Any vector A is there, just listen, any vector A. And any other vector B is there. B. When you are going for addition of two vectors, okay, A and B, then what you are doing? You are making one vector as it is, like A vector you will be leaving it untouched. Another vector B, what it is here, that you will be bringing it here. So along, this is called head, this is called tail. Head and tail. Okay, so any vector will be having its head and tail. Okay, so now, in this case, this vector's tail, we will be bringing it here and exactly parallel to it, we will be drawing from here. Okay, so now the vectors are joined. Now the vectors are joined together A and B. Okay, now what you will be doing from this particular point, initial point of A vector, and you will be joining the final point of B vector. Okay, so this will be giving you in this direction. So this is A plus B. So this is addition of vector, but there is no subtraction of vector. Addition of vector we are having, but there is no subtraction of vector. Okay, now suppose you are having any vector like A in this direction. When you are making that vector in reverse direction, it will change its magnitude. Due to the direction change, it will be having negative. There will not be any change in magnitude. Direction change only is taking place. So due to the direction change, it will become minus. So it will be negative vector. Okay. So now suppose. So that's why I am telling that there is no subtraction of vector. Subtraction of vector is not written anywhere. Only addition of vector. Addition of vector. So now you have seen this one. Suppose this B vector, I will reverse its direction in this way. Okay. Then it will become minus B vector. Yes or no? Then again we can add vector how? So we will be joining the